Good morning. Today we're talking about the dosage of urinary 1.2 cyclohexanediol, using an exclusive kit for the specific analysis and using a gas chromatograph combined with a mass detector and a FID detector. The trans 1,2 cyclohexanediol, together with 1,4-cyclohexanediol, is one of the products of the cyclohexane metabolism. It is present in the urine of subjects exposed to these solvents, but also to substances such as cyclohexanol and cyclohexanone. The metabolization of cyclohexane by liver microsomal enzymes leads to the formation of diols. In a survey conducted on subjects exposed to cyclohexane, the various urinary metabolites were found in the following proportions: cyclohexanol 0.5%, 1,2-cyclohexanediol 23.4%, 1,4-cyclohexanediol 11.3%. The metabolic pattern is particularly the same for exposure to cyclohexanol and cyclohexanone. The elimination half-life of the diols following inhaled cyclohexane exposure is 14 to 18 hours. The instrumental technique used for the determination of trans 1,2 cyclohexanediol is gas chromatography with a flame ionization detector (FID), but a mass detector may also be used. This method is applicable routine to the biological monitoring of subjects professionally exposed to cyclohexane. The possibility of simultaneous exposure to cyclohexanol and cyclohexanone, which leads to excretion of the same metabolites. From the analysis of the correlation between the cyclohexane environmental data and the urinary concentration of metabolites, it has emerged that the most reliable indicator is the trans 1,2 cyclohexanediol because it is more sensitive, specific, better correlated with the external dose of these solvents. Using the sum of the two indicators, the trans 1,2 cyclohexanediol and the 1,4-cyclohexanediol, do not obtain better results, and therefore it is sufficient to dose 1,2 cyclohexanediol. Let's start now to illustrate the method to determine the trans 1,2 cyclohexanediol in urine matrix. What do we need for this analysis? GCMS or mid-level FID, ready-to-use kit, lyophil controls level 1 and 2, HPLC grade water, micropipettes and tips with variable volume, standard vials, caps for vials, vortex, urinary samples taken at the end of the work shift, installation and conditioning of the gas chromatographic column VF wax MS 30 meters according to the specification reported by the manufacturer, Pyrex tubes, dry stove, rotating or linear tube stirrer. Let's take as an example an analysis session of 7 urinary samples on which to perform the 1,2 cyclohexanediol dosage. Together with these samples, we will also analyze a urinary calibrator, which we will use to automatically build the calibration curve on the software, and 2 level 1 and 2 urinary controls that will be useful to check the calibration curve and therefore the whole analytical session. We prepare many Pyrex tubes, including samples, calibrating standards and controls. Dispense 2.5 ml urinary calibrator, urinary controls and urinary unknown samples into the Pyrex tubes. We also add to each vial 500 microliters of reagent B, hydrolysis reagent. We close the tubes and maintain at 110 degrees Celsius for 1 hour. After cooling to room temperature, add 1 ml reagent D, neutralizing solution. We then vortex, paying attention to the fact that the heat develops in this session. Therefore, the tubes should be allowed to cool at room temperature. In the next step, we add 2.5 grams of reagent E, stabilization solution, resulting in the formation of a precipitate. Then we arrive at the last passage where 1.5 milliliters of reagent F, extraction solution, with internal standard are added. At this point, the tubes are closed and are vortexed for a few seconds. Then they are placed on a rotary shaker for 10 minutes. Subsequently, the sample are centrifuged for 10 minutes at 3000 rpm. In the meantime, we move to the gas chromatograph to activate the instrument method uricacate 1,2-cyclohexanediol, so that the system sets itself to the correct flows and temperature. The machine on which we perform these tests is a gas chromatograph with a FID detector. Immediately afterwards, we transfer the supernatant into the vial standards that are placed in the autosampler tray. Starting with the calibrator and continuing with the two controls and the samples. Let's start the acquisition automatically. The chromatographic runtime is 26 minutes, and for this sequence of 7 samples, all results will be obtained, including calibrator injections and 2 controls, in just over 4 hours of instrumental work. This is a typical chromatogram in which the peak of 1,2-cyclohexanediol is at 15.9 minutes and the peak of the internal standard comes out at 8.7 minutes. The time taken for this analysis is as follows: 15 minutes to prepare 7 samples, 1 calibrator, and 2 controls with the hydrolyzed reagent, 60 minutes incubation at 110 degrees Celsius, 50 minutes to add in order the neutralization solution, the stabilizer and extraction solution, 10 minutes in the rotary agitator, 10 minutes in the centrifuge at 3000 rpm for a total of 2 hours of preparatory phases, 270 minutes to analyze all the samples. In these conditions, we are able to report all 10 samples in about 6.5 hours. Ultimately, the use of the uricacate for this analysis of 1,2-cyclohexanediol allows you to get sensitive and accurate results, provide appropriate reports, take full advantage of your equipment. In the next few days, we will send you the method where you will note method recovery equal to 98%, linearity range from 1 to 300 mg per liter using a mass detector, CV % less than 5%. Currently, the uricacate that I presented is the only ready-to-use kit on the market for the dosage of 1,2-cyclohexanediol. And now let's briefly summarize. In this video we have highlighted the importance of the determination of the level of 1,2-cyclohexanediol in urine in occupational toxicology, viewed the simplicity of the use of the kit to perform the analysis of 1,2-cyclohexanediol in the urine, shown the performance of the method regarding speed of execution of the analysis, reliability, linearity, accuracy, reproducibility. If you enjoyed this video, do not miss the next one. Best wishes and see you soon!